Okay, here we are for the midterm, and this is Objective 1, William Schwab. And here's the code that we're doing. And the first objective is we're going to take a little temperature sensor, and when it goes over a certain threshold, we're going to operate a motor via a potentiometer. And we'll take a look at that in a second. Okay, here's our code for the temperature sensor, and we just do some initialization. We have our servo main set up, and we have attached to pin 10. We read the pot value, and we put little delays in here after we read the A to D converter just so it can settle out. Once we read the value, we map it, and now again we're mapping our analog to the 20 to 140 that the servo needs. And then we also read the temperature sensor voltage. First we convert it to millivolts, and then we convert that into degrees Celsius and degrees Fahrenheit. And if we're above a certain threshold, we have it at 72 since I'm in the library right now and it's fairly cool in here. Then we run the motor, and we put the map value, which again is from our pot, and that'll be the value we go at. And then we have our serial line so we can look at it. And right now if we look at it, our serial monitor, we can see that we're at a fairly cool 70 degrees for the most part. And I'll warm it up and we can see what happens with the servo. Okay, now here's our setup with our motor and our temperature sensor. And I'm going to take the temperature sensor and warm it up. Again, we start at about 70, and we get pretty quick, we go up to speed. And when our temperature sensor is warm, now we can adjust the speed by the pot. And we can see that we slow down, and again, because it's the pot, we can reverse it in the other direction, and we can go down in speed. And so that's clockwise direction, and here we're going counterclockwise when viewed from above. Now the only thing about it is when we get back close to our 70 degrees, the thing starts shutting on off type deal. So it gets a little confusing, but that's objective number 1. Okay, here's objective number 2, and this is where we use the LCD. And so we include the library for liquid crystal display, and then we initialize the LCD interface of pins for the Arduino, and then we go here, we just do some setups for it. And when we come down here, we have a pot value, we read it, we analog read it, and then we send that value out to the LCD. First we print hello world, and then we print the pot value, and we delay the 1 second. And in a second we'll see what happens with our little Arduino board. We're loading the code for the Arduino now, and it's going on. Oh, look at that. And now what we have is we're just showing what the pot value is with the hello world. And we can adjust the pot value, and as we go down to 0 we get the best contrast. And then as we slowly go up, and our pot is not very smooth, but you can see the contrast gets worse and worse. And right about 1600, 1800, it's really hard to see. So what we can do is we can just hardwire the contrast pin, because we know from going down there when it's at 0 we get the best contrast, and then we can see what happens. And we'll be back in a second. Okay, now all we've done is we've hardwired the contrast pin directly to ground, and so it doesn't go through our pot. So now if we adjust the pot, we can see that the pot goes through the full range of values, and it's 10K pot. So what we do is we'll just run it up, and you can see that it'll go all the way up to 10,000. Now we can't do this because you couldn't see the contrast if we had it above like 2K, but that's the end of objective number 2. Okay, here we are with objective 3, and this is just marrying the temperature sensor to the LCD. Seems simple enough, right? Okay, over here is our code, and the only really part of it was trying to get the output, and we had to use string characters. And so we do the same thing with initializing liquid crystal and also the temperature sensor. But then we have to do a bunch of stuff to try to get into the right string format, so we have to convert our actual temperature from a float to a string. Start our program, see what we have. And the program's loading over here. And there we go with objective 3. And right now we can see the voltage, and as I grab the sensor, and it doesn't take long for the temperature to start going up pretty rapidly. And then we can come down and it'll stabilize also fairly quickly. So that is objective number 3. Okay, here's our fourth and final objective. And what we have is push buttons controlling our motor, one clockwise, one counterclockwise. If neither or both are pressed, we do nothing. And then the speed depends on the position of the pot. Our code looks something like here. We have our include servo, some initialization, and what we do is for our truth table is when we have our clockwise push button set, we have the value, map the value from the pot to be less than 90 degrees for clockwise, and then counterclockwise it's going to be more. And so the way we negotiate it is if clockwise is set, it's going to be 20 to 89 to have slow motion, and then counterclockwise will be 97 to 140. And so we have our if statement, we make the proper map, and then we also have LEDs to tell us whether we're going clockwise or counterclockwise. The blue LED is clockwise. And so let's take a look at what, and so we have clockwise, counterclockwise, and then else will just be if neither button or if both buttons are pushed, and that'll turn the motor off. And so in a second we'll see what happens. Okay, and here's the setup for the fourth one. We have our pot, our motor with a little flag on it. We have some LEDs. Green is counterclockwise, blue is clockwise, and then we have our buttons. The one with the Arduino logo is clockwise, and it's over by the battery. And let's see what happens. Now our pot is set up so right about this position is slow, and when we press either one of them, it'll be slow for whichever one we press. So the pot has just got a slow to fast revolution. It doesn't change depending on what position you're in. So here's slow clockwise, and our blue LED is on. Slow counterclockwise, and our green LED is on. Now we'll use the pot to increase the speed, and then we'll bring it back down, and then we can do the same with the other one. So first we'll go counterclockwise. And now clockwise. And that is objective 4.